Today we will be reviewing Chapter 4, which is about the structure of atoms. We will be reviewing early ideas about matter, what atoms are, how atoms differ, and unstable nuclei and radioactive decay. The guiding question is, why are humans 99% empty space? By the end of this review video, you will have a clear idea of why humans are 99% empty space. First, we will be reviewing some early ideas about matter. The first person to propose the existence of matter was the Greek philosopher Democritus. He believed atoms were solid and indivisible. However, his theory was rejected by Aristotle, a more prominent Greek philosopher who didn't believe in the existence of atoms. Due to this, atomic theory was rejected for thousands of years. Later, in the 18th century, an English chemist named John Dalton proposed an atomic theory with 5 main points. 1. Elements are made of extremely small particles, called atoms. 2. Atoms of a given element are identical in size, mass, and other properties. Atoms of different elements differ in size, mass, and other properties. Atoms cannot be subdivided, created, or destroyed. 4. Atoms of different elements combine in simple whole number ratios to form chemical compounds. And 5. In chemical reactions, atoms are combined, separated, or rearranged. Although we now know atoms can be further divided and all atoms of an element are not identical, Dalton's atomic theory helped explain the law of conservation of mass and the law of definite proportions and was revolutionary for its time. Current atomic theory is now based upon the quantum mechanical theory of the atom, but that is covered in another chapter. Now we will review what atoms are. An atom is the smallest particle of an element that maintains the properties of that element. The basic structure of an element is a centrally located nucleus and a cloud of electrons. The nucleus is composed of neutrons and protons and makes up the majority of the mass of an atom. The cloud of electrons makes up most of the volume of the atom, but most of an atom is empty space. Since all matter is made of atoms, and we are made of matter, we are 99% empty space. Some basic characteristics of neutrons, protons, and electrons are that neutrons have a neutral charge, protons have a positive charge, and electrons have a negative charge. Additionally, neutrons and protons have approximately the same mass, while electrons have a mass of 1 over 1,840th of neutrons and protons. Now, we will review how atoms differ. Atoms are distinguished by their number of protons, which is its atomic number, which is the same as its atomic number. Another way to differentiate atoms is by their mass number, which is the sum of its neutrons and protons. Atoms of the same element with different numbers of neutrons are called isotopes. The atomic mass of an element is the weighted average of the masses of all its naturally occurring isotopes. Now, we will take a moment to review how to find the atomic mass of an element. Pause this video and use the information on screen in the chart to find the atomic mass of titanium. If you got 47.89 MUs, you are correct. If you had trouble, you can pause this video again to take a look at my work. Finally, we will review unstable nuclei and radioactive decay. First, we must differentiate between chemical and nuclear reactions. Chemical reactions involve changes in the electrons surrounding an atom, and nuclear reactions involve changes in the nucleus of an atom. Unstable nuclei become stable by emitting energy in a spontaneous process known as radioactive decay. This energy is radiation, and radioactive decay is a nuclear reaction. There are 3 types of radioactive decay: alpha radiation, beta radiation, and gamma radiation. This chart summarizes the properties of these particles. Alpha particles are a helium atom with positive charges, with a positive charge of 2. Beta particles are basically just emitted electrons, and gamma rays are just high-speed radiation. Using this information, we can determine what effect these types of decays will happen on atoms' atomic number and mass number. Alpha decay will decrease the atomic number by 2 and the mass number by 4. Beta decay will decrease the atomic number by 1, but leave the mass number unchanged. And since gamma radiation is basically just releasing high energy radiation, it will leave the atomic number and mass number unchanged. Now that we know how nuclei become stable, how do we know when an atom is unstable? Well, we can determine if an atom is stable or unstable by looking at its ratio of neutrons to protons. Now we can answer the guiding question and say humans are 99% empty space because we are all made of atoms, and atoms are mostly made of empty space.